In this lesson, we shall focus on mathematics, MATH141 CALCULUS, a UKZN module. We shall do arc length calculations, but also we shall spend time on actually areas of surfaces of revolution as follows. Right, now we begin by looking at the length of a plane curve. In this section, we'll use the tools of calculus to study the problem of finding the length of a plane curve, the arc length. Right, so our first objective is to define what we mean by the length, also called the arc length of a plane curve. Y equals f of x over an interval from A to B. Figure 5.4.1. So we're interested in finding what we call the length, also called the arc length of a plane curve. Right, y equals f of x over an interval from A to B, which is a closed interval, like in the figure 5.4.1. Now, once that is done, we will be able to focus on the problem of computing the arc lengths to avoid some complications that would otherwise occur. We will impose the requirement that f prime be continuous on AB, so the derivative needs to be continuous on AB, closed interval AB, in which case we will say that y equals f of x is a smooth curve on AB, or that f is a smooth function on AB. Thus, we'll be concerned with the following problem. Now, 5.4.2, the definition. If y is, so we're defining arc length now. It's very important we focus on how it is defined so that we can be able to solve it accurately. If y equals f of x is a smooth curve on the interval AB that is closed, then the arc length of this curve over AB, closed interval AB, is defined like this. So we require that f be a smooth curve on the closed interval AB. If it is a smooth curve, then the arc length L of this curve over AB is defined as L equals the integral from A to B of the square root of 1 plus f prime of x squared dx. This result provides both a definition and a formula for computing the arc lengths. So here we have both a definition but also a formula. Where convenient, 3 can also be expressed as follows. So now, sometimes where it is convenient that we can actually, note that this f prime of x is actually can be written as also what? dy dx. Yeah, f prime of x, sometimes where convenient, 3 can be written as the f prime, can be written as dy dx, and everything else remains the same. Moreover, a curve expressed in the form x equals g of y, where g prime is continuous on CD, the arc length L from y equals c to y equals d can be expressed as arc length, which is from c to d of the square root of 1 plus g prime of y squared dy, the integral from c to d of the square root of 1 plus dx dy squared dy. Right, so sometimes we note the change that if it is g prime of y, it is dy, f prime of x is dx, but also if it is dy here, then it is dx dy under the square root sign. We continue as follows. Right, so now we need to find the arc length of the curve. Right, this curve is defined from 1, 1, the point 1 and 1 to the point 2 and the square root of 2. Figure 5.4.4 in two ways. Using formula 4 and B using formula 5. So you're going to use formula 4, but also you're going to use formula 5. Right, so if you look at these and look at these very carefully, what is formula 4? Formula 4 is clear that at this point you have the arc length, which is A to B 1 plus f primed of x squared dx, which is the integral from A to B of the square root of 1 plus dy dx squared. And this is exactly the same as what? Exactly the same as dx. Right, and now this here is actually our formula 4, which you need to use. Simultaneously, we know that at this point, our y is actually equal to 3 over 2. And let us find the derivative of this. The derivative of this becomes dy dx, which is 3 over 2x to the power. Now, the 3 over 2, you subtract 1 from it, and so you get 1/2, like this. And that gives us dy dx using formula 4. But this can also be written as 3 out of 2, then the square root of x. And we continue like this. If then you integrate from this point to this point, obviously, it gives you the x coordinates. X, for instance, runs from 1 to 2, whereas y runs from 1 to the square root of 2. Right. And with that mentioned, we are able to see, therefore, that we can, like we did in the morning, 1 plus dy dx squared is 1 plus, what is dy dx? It is 3 out of 2, the square root of x, and you square this, which is 1 plus, you square the 3, you get a 9, you square the 2, you get a 4, you square the square root, becomes only x, like so. Okay, so this gives us exactly that. So we've computed the 1 plus, so we can just take the square root after that. Therefore, you have the integral from 1 to 2. Now, if you have 1 plus dy dx, you square it, it's 1 plus 9x over 4. And then dx. Okay, we continue. We continue. Now, we need to just deal with this one. Let us take a look at this arc length and actually be in a position to arc length equation that we have got. And then just compute this. How do we compute this? We let u 1 plus 9x out of 4, which means that du is 9 out of 4 dx. Like we did last time, so we draw a small thing, a small cross. There are x limits of integration, but also there are u limits of integration. 1 to 2. Right, so now if x is 1 here, if x is 1, what is u? So you're going to have 1 plus 9 over 4. 1 plus 9 over 4 is equal to what? It's equal to exactly like 4 plus 9, which is like 13 out of 4. Simultaneously, if you have the 2, you put 2 here. You put 2 in the place of x, it's going to be like 9 over 2, and then it's going to be 11 out of 2. At this point, we do the integral from 1 to 2, and we have the square root. 1 plus 9x out of 4 dx, which is the integral. Can you do it on the reverse side? So now we already have the integral from 1 to 2. So the arc length is this one, which is 1 plus 9x out of 4 dx. And we've already seen that here, if you integrate from 1 to 2, it's the same as integrating from 13 out of 4 to 11 out of 2. Right, and then now, right, and then you have the dy dx as I'm here in class now. Shingi, I'm in class. Yes, how are you? I'm in class, Shingi.
Send me, I will see you next week. Send me the assignment.
All right, that's fine. Did I not send you? I thought I sent it to you.
No, you didn't.
Oh, I thought I did. Let me just check.
Just send the cover, sort of like that.
Oh, okay. Okay, that's fine. I understand now. Okay, I'm going to send it to you. Okay. Okay, thanks, Shingi. Goodbye. Okay, right. So dx, what is dx out of this? Dx is actually the same as 9 out of 4 du. So dx is 9 out of 4 du. Dx is 9 out of 4. So you flip it around, and then in the place of dx, you get 9 out of 4. 9 out of 4? 4 out of 9. Yeah, so dx becomes 4 out of 9. Yeah. So it becomes 4 out of 9 du. And this is equal to what? You can pull out the 4 out of 9, then you have the integral from 13 out of 4 to 11 out of 2, and therefore it becomes u to the 1/2 du. Meaning L is therefore the integral from 4 out of 9, and then you find the integral of this, which is 2 out of 3, u to the 3 out of 2, the integral from 13 out of 4. So 13 out of 4, 11 out of 2. 4 by 2 is 8. 27. 11 out of 2. 3 over 2. 13 out of 4. 3 over 2. Okay. So now, this is what we're getting. Let's take a look at these. Let's take a look at these exactly. Right, so we think about this and see if this is exactly what we want or not. Right, so let us check this and see if it is exactly what we want. Let us check if it's exactly what we want. It is exactly what we want. And this answer can also be written as what? It is the answer. But this answer can be written nicely. But how so? Okay, because this is like 3 over 2, 3 over 2. So you can also write it as 11 out of, like 8 out of 27, excuse. 22 out of 4. 3 out of 2. 13 out of 4. 3 out of 2. So Okay, yeah, you get this. Now, this thing here, I mean, we're done. But you can write it as 22 to the power 3 out of 2, and then the 4 is the same as 2 squared. And then the 2 cancels, giving us exactly 2 cubed. And what is 2 cubed? It's 8. Minus even this one is 13 to the power 3 out of 2, and then it is out of 8. This cancels, and then you have 22, the square root of 22, 13, the square root of this. You divide by 27, like so. Okay, because the 3 over 2 is the same as 1.5. So it's 1 plus 1/2. This is to the power 1, and the square root means that it is to the power 1/2. Okay, let us just, well, it's not necessary, but we can just, show with the calculator that the answer is that. And then we move on to the next approach, because we're supposed to use the formula 4. So we spoiled for choice. The formulas are galore, and we decide which one to use. So 22, the square root of 22, then we minus 13, the square root of 13, you divide by 27. And this is therefore 2.09, 2.09 approximately. So this is approximately 2.09. Approximately 2.09, and therefore this is the answer. But now, look, we're using formula number 4, but obviously we can use formula number 5 as well. So in A, we use formula number 4. So we're doing part A, and then now we're going to do part B. So now we solve for X. Okay, because now remember that the other formula says the integral from A to B, the square root of 1 plus f prime of X is the arc length, like this. It is gy, in which case it is exactly this one here to me. So it's exactly this one here. So it's c to d g prime of y, and then dy until c to d, then you have dx dy, then dy. Okay, so let us use the c and the d limits of integration. You have c to d, then you have 1 plus g prime of y. You square it, dy, which is the integral of c to d, 1 plus dx dy dy. Okay. Now let us take a look at this one here. But we remember that our y is x to the power 3 out of 2. But we need to get dx dy in the formula number 5, which is this one, formula number 5. But now, to make x the subject, we need to solve for y. We need to solve for x, rather than make x the subject. And to do that, to make x the subject, we need to raise to the power. So y is raised to the power 2 out of 3. And 3 out of 2. And this one is raised to the power 2 out of 3. Y is raised to the power 2 out of 3. And therefore, 3 cancels and 2 cancels, giving us exactly x. Now that we've made x the subject, we can, from this one, henceforth find dx dy. And then we can find the 1 plus the square. Right, so what is dx dy? So you bring down the 2 over 3 x to the power. So if you subtract 1 from this, you get minus 1/3. Like that. And then it remains to compute like usual the 1 plus dx dy, and then you square it. Okay, so now which is 2/3 x to the minus 1/3, and then you square it. 1 plus 4 out of 9 x to the power minus 2 out of 3. Yup. Okay, this is all y. This is all y because it's dx dy we're finding. So it's all y. It's all y. To evaluate this integral now, we're going to put everything here under the square root so that the arc length, L, is this one from C to D, which means that it's going to be from y equals 1 to y equals 2, the square root of 2, from y equals 1 to y equals 2, the square root of 2, then we have the square root. 1 plus now, yeah, okay. The 1 plus dx dy squared is 1 plus 4 out of 9 y to the minus 2/3. And then it is actually dy. So now we have this one here and need to compute it. The integral from 1 to 2 the square root of 2, the square root of 1 plus 4 over 9 y to the power minus 2/3. dy. So now, this is exactly what we have here. The question then becomes, what do we do here? Okay, we need to integrate this one. And to integrate this one, we can take out a common factor. And what will the common factor be? Let us take out 1 out of 9. Take out 1 out of 9, therefore the square root of 9 is 3, so that it becomes 1/3, 1 to 2, the square root of 2. Okay, this one is a bit hectic. And then if you take out the 9, therefore this is going to be exactly what? Right, it's going to be exactly what? Okay, not only take out 9, let's take out 9 together with its multiplicand, the factor it is associated with. So let's take out the, okay, we want to integrate this now. I mean, that is the objective. So we can take out the 1 out of 9, and then it becomes 1/3, 1 to 2, the square root of 2. And then if you take out the y to the power minus 2/3, you take the square root, which is the square root, which is 9 to the power 2 over 3 plus 4 dy. Okay, we can write this, because if you take the square root of this, when you take it out, the y to the power minus 2/3, check the square root cancels these 2, giving us minus 1/3. Okay, you get to this, and then now we need to evaluate this integral here. And to evaluate this integral here, it's easy. Let u be everything under the square root. 9y to the 2/3 plus 4, then the derivative, which is 18 out of 3, 6. Subtract 1, you get minus 1/3. dy. xy. Okay, no. Change of variables. We are changing right now from the variable y to the variable u, because u is our new variable. Y is from 1 to 2 to the square root of 2. Okay, if this is true, then you'd have that okay, yeah, from 1 to 2 to the square root of 2, and then the u, if you put 1 here, it's going to be, yeah, you put y equals 1, it's going to be 9 plus 4. 9 plus 4 is exactly 13. And then if you put 2 to the square root of 2 here, is the same as putting the 2 to the square root of 2 is the same as 2 to the power 3 out of 2, because the 2 to the square root of 2 for y is the power half for the square root and power 1. So 1 plus half is 3 out of 2. And then you have 2 out of 3 plus 4. 3 cancels, 2 cancels, which means it is 9 plus 2 plus 4. 18 plus 4 is 22. Like so. Exactly like so. Okay, we're good. Let's continue. You're going to participate in some of these questions and see, I mean, there are many exercises we shall do from the textbook. And then also, I mean, these things will be, some of the third questions are from the book. So once you can do most of the textbook exercises on the arc length and then the surface area, then you'll be very, very okay. Right, so now, let us see what we got here. Okay, what we got here now, we need dy. There are many things, already got it, we already got it. Because already the y to the power minus 1/3 and dy is what we want, but we can otherwise make just dy the subject as usual. And if you make dy the subject, you divide by the 6, and then it becomes this, du. And then now you integrate from 13 to 22. Y to the power this. So you raise it to 3, and you have the square root of u. And then what is dy? dy is 1 out of 6, 1/3 du. So you cancel this, and then you have 1/6. And then 1/6 and that. 1/3 and 1/6. Check. This means L is 1/3. And then you have 13 to 22. Y to the power that. So that you have 1/6 y to 1/3. du. So you have 13 to 22. This cancels. This cancels. U to 1/2 du. Like that. So now, what is the arc length? 1 out of 18, and then we find the integral of this, which is 2/3 u to the power 3/2. 13 to 22. You take out the constant, it becomes 2 cosine times into 18. Goes 9 times, giving us 1 out of 9 times 3, 1 out of 27. Okay. So u to the power 3 out of 2. 1 out of 27 22 to 3 out of 2, 13 to 3 out of 2. Yeah? This answer is arc length. 22 to the 3 out of 2 is 22. The square root of 22 minus 13, the square root of 13, all divided by 27. All right, that's what we're getting. This is exactly the same answer, which is approximately 22, the square root of 22, the square root of that. Which is exactly 2.09. 2.09. Right, so now we're good. Any question? Okay, I believe this is very obvious, like obvious. Okay, this is recorded, but also you'll have a chance to watch this. Let us look at the arc length. Find the exact arc length of the curve over the interval. This one is from 0 to 1. So now, if you're dealing with this one, number 3 is the business of at the moment. Y to the power, y equals 3x to the power 3 out of 2 minus 1. Let's find the derivative. Let us find the derivative. So the derivative is actually given by dy dx. And now we can use any of those. Yeah, so we choose which one is going to work. Let's try dy dx. If it's difficult, this one to integrate, then you can use dx dy. So we spoiled for choice. We know both formulas already for the arc length. So we're going to use, yeah, let's do dy dx. And then it is, you differentiate this one, you bring down the 3 over 2. 3 by 3, it's 9 out of 2. X to the 1/2. All right. 1 plus dy dx. 1 plus 9 out of 2, the square root of x. 1 plus 81 out of 4x. Okay, because if you square 9, you get 81, and then you get exactly that one. Let's finish this off. So what is the answer? Okay, then we do the arc length, but it's for the x. So we're going to use the formula a to b. Okay, you can just put everything here. You can just substitute just to avoid wasting time. So x is from 0 to 1. 1 plus dy dx squared dx. Okay, we can still put, just to make sure somebody's aware of the formula we're using, but doesn't really matter. A to b, 0 to 1, the square root. 1 plus that is 81 out of 4x dx. Okay. Now, when you get to this one, we perform some basic integration. So we're going to let u be exactly 81 out of 4 dx, rather 81x out of 4. So in other words, we let u be 1 plus, excuse me. U is exactly that. So now, what is du dx? Is 81 out of 4 dx. You do this one here. xy, so that x is 0 to 1. Okay, now, if we put 0 in the place of the x here to get the u, this is going to be 0, and then u is 1. If you put x equals 1, then u is going to be exactly 85 out of 4, which is the integral from 1 to 85 out of 4. Then the 1 plus 81 out of 4 is u. Dx is 4 out of 81 du. 4 out of 81. You find the integral, which is 2 over 3 u to the power 3 over 2. So now, in the end, which is not, let's simplify this one. 4 by 2 is 8, and then what is 81 by 3? Yeah, 243. This is 8 divided by 243. Right? U to the power 3 out of 2. 1 to 85 out of 4. Okay, 1 to 85 out of 4. Let's substitute everything here. 8 out of 243. 85 out of 4. 3 over 2 subtracted 1. And this is the answer. Right, this is the answer. It can be written in so many ways. For example, you can write it as 8 out of 243. And then this one is exactly 85 to the power 3 out of 2. Then 2 to the power 2. 4 to the 4. The 4 is 2 to the power 2. The 2 cancel. 2 to the power 3 is 8 minus 1. So which means 1 over 243. 85, that, and then you minus 8. Which means you have 85. 85 minus 8 over 243. So this is the arc length. This is the exact arc length. You need to find the exact one. So it means that you don't need to, estimate anything. Now this one, we're going to use formula 5. Let's continue. Let's do number 4. This one, number 4. X is equal to 1 out of 3 y squared plus 2 to the power 3 out of 2. Okay. Now we continue. Now, because now we have x already the subject, we can just find the x dy. Bring down the 3, it becomes 1/2. Subtract 1 becomes 1/2. Then the derivative becomes 2y. And then it becomes y like that. Okay, then you have that. And then you square this. Okay, let's use a different color. So which is 1 plus. Yup. Yeah, what are we doing here? Okay, it's exactly this, but you need to square it. So you need to square. It's fine. So it is exactly this. Okay, let me write the thing properly here. Let me write clearly because I think the powers are just mixed up a little bit. So you're going to have exactly now these particular open parentheses. Y plus 2, and then you have 1/2, and then you square this. Okay, yeah, let's do the... Okay, yeah, you square this, and it's going to be y squared. Then you have y squared plus 2. Like this. And this is exactly what? It's y to the 4th power, 2y squared plus 1. It's a biquadratic equation. This is biquadratic. 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 And therefore, you can write it as y squared plus 1. And then you put the square like this. We're good. Sure that this, you can see that you can get 100% in this section. So that now, objects shall be moving to the dots. But now we got exactly this here. So we're doing the 4th one. So which means that the arc length, it's the integral from c to d of the square root 1 plus dx dy. You square it. And then it is raised to the power. It is raised to, it is, there is a dy here. Then I use formula number 5. But the y already we know is from 0 to 1. You have the square root of 1 plus, what is the r? Okay. The 1 plus dx dy squared is this one, which is y squared plus 1. dy. You take the square root, which is y squared plus 1. Because the square root now removes the square. How awesome is this? It's like oil poured over the head of Aaron that started trickling down his beard. This is how beautiful this is. If you find the integral of this, 1 out of 3 y cubed plus y, and then obviously this is performed from 0 to 1. You substitute the 1 and then the 0 goes away. And substitute the 1, you get 1 over 3 plus 1, you get 4/3. 4/3 cubic units. Cubic units. Right, it is my hope that so far so good. Let us do number 5, and then we shall jump to the surfaces, and then we should do the touch also. Let's do number 5. Number 5 is y equals x to the power 2/3. But now this one, we're going to actually try to use formula 4, and then we can use formula 5 as well. Because now y is already the subject, so we can use formula 4. Getting dy dx 2/3. Minus 1 minus exactly 1/3. It's exactly something we saw before. right? But doesn't look pretty for us, but it's okay. Because if you make x a subject, then this is going to be 3/2. And then if you find it derivative, it's going to be nice. Okay, that's what I'm going to do. I'm going to make it much easier. So to make it much easier, you can look at the powers as well. Because if you look at the power, it's the same thing. Doesn't matter what you do. You can use formula 4, formula 5. But now if you look at this one, is 2/3 like this. The power is not nice because if you subtract 1 from this through the derivative, it's going to be minus 1/3. Cringing is not the best of things. But now, if you're going to make x a subject, you raise it to the power 3/2. X to the power 2/3, you raise it to the power 3/2. Y to the power 3/2, and then these 2 cancels, 3 cancels, giving us x. Dx dy. Okay? Now you can get dx dy. You can change the question and make x a subject, make y the subject. So now we have this, and you subtract 1 from the power. So 3/2 subtracted 1 gives us 1/2. How beautiful is this? But so beautiful. Because now you're going to square these. That is why it's nice when it is like power 1/2, because when you square the square root, it goes away. So it becomes a very beautiful strategy, and you have exactly the square root of y this way. Simultaneously, this is 1 plus dx dy, you square it. 1 plus, if you have the dx dy, 3/2 the square root of y, then you square it. You square the, yeah, I'm going to give some homework here. Some of these very similar to the things we saw in the test, yeah, that's fine for the surface. Okay, so if you square the 3, it becomes a 9. You square the 2, it becomes a 4, and then it becomes that. Now, which means that L is the integral from c to d of the square root. 1 plus dx dy, and then you square it. Dy. You'll have the integral now. Okay, so we need to reason carefully. You see, there are a couple of things that are very important here. We changed the subject of the formula, so we need to change because these are x limits of integration, so we must get y limits of integration. X was from 1 until 8. What will y be? We ask the question. So now if x is 1 here, y is also 1. If x is okay, x is 8. In the expression 2/3, but you already have x is 8 to the power 2/3. 8 is 2 cubed to the power 2/3. 3 divides, and then you have 2 to the 2, which is 4. So which means y is going to be exactly a 4. Take note. Take note. So that you have 1 to 4. The square root of the 1 plus dx dy squared, it's 1 plus 9/4y. Then you have dy. Okay, we just need to integrate this one, something similar to what we saw already. So if we integrate now, perform the integral using formula 5, c to d, well, let's forget about c to d. We've already seen that one. Let us just do this one here and say from 1 to 4. The square root of 1 plus 9/4. Y dy. All right. So what we get, we integrate this one. We need to let u be 1 plus 9 out of 4 y, which means that you have du. The derivative of this one is 9 out of 4 dy. So now you have y and then u. Y is from 1 to 4. The limits of integration. U, if you put 1 here, it's going to become what? Yeah, y equals 1 and then becomes 13 out of 4. If you put 4 here in the place of the y, it's going to be 9 plus 1. And what is 9 plus 1? 9 plus 1 is exactly a 10. Okay, put the 4 in the place of the y, because y is 4, then it cancels out. Therefore, now you perform the integral from 1 to 4, the square root of 1 plus 9 out of 4y dy. This is the same as integrating. Now, if you integrate from 1 to 4, it's the same as integrating from 13 quarters to 10. U dy. Oh, I lost you. 9 is exactly 4 out of 9 du. 4 out of 9. Yeah, the integral from 13 quarters to 10. U to the 1/2 du. 4 out of 9. 2 out of 3. U to the power 3 out of 2. 3 out of 4, 10. It becomes 4 by 2 is 8. Out of 27, u to the power 3 out of 2, the integral from 3 out of 4, 10. 8 out of 27, you plug in the 10, it becomes 10 to the power 3 out of 2 minus 13 out of 4 to the power 3 out of 2. And this is the answer. Remember, you need to find the exact arc length, and this is the exact arc length. There's just nothing more, nothing less. Okay, sorry. We are on question 5. We are on question 5. We are on this question. I'm so sorry. Your phone disconnected, so but we are recording this discussion. Right, we're on question 5. All right, I'm just sorry because I don't know how the disconnection. Okay, but yeah, this is recorded, so you'll have access to everything, and therefore this is the answer. In other words, we are saying actually the answer to number 5 is the arc length. 8 out of 27. And it is 10 to the power 3 out of 2 minus 13 out of 4 to the power 3 out of 2. Look, I'm not, yeah, we're going to take a break at 7:30, and then we're going to be coming back at 11 o'clock at night, just after 12:30. So we actually have that L is this. And if L is that one, we then have exactly the following. Okay. This is already the answer. But again, this answer can be written in so many ways. So which means that L is 8 divided by 27. Then the 10 to the power 3 over 2 is 10 the square root of 10, which is 13 the square root of 13. 2 to the 2 is 4 is the same as 2 to the 2. 2 to the 2 cancels, which 2 to the 3 gives us 8. Like that. Good. That is the answer, but you can write it in many counting ways. For example, you can write it as 8 by 10 is 80. The square root of 10 minus 80, the square root of 10 out of 27. Okay, the 8 cancels, giving us 13, the square root of 13 out of 27. So the 8 cancels, and then now the arc length would be given by 80, the square root of 10. 13, the square root of 13, and everything is out of what? Out of 27. So yeah, this is the exact arc length. Is the exact arc length. Okay, we're going to take a break now. I'm going to send you the recording because it's not very long. We're going to take a break now, and then we're going to be coming back at 11. And then at 11, we shall push as much as we can. Shall go on and on and on. Because I have another class that's starting at 8. So I'm going to have a class at 8 from 8 until 10. That's the reason why I'm saying 11, because if I have a class at 8 until 10, then even if I run late from that class, but by 11, I'm going to be done, and then we can start at 11 and then cruise and cruise and cruise and cruise and cruise. But we did the arc length now. So I'm saying the homework 6, 7, 8 are homework. So 6, 7, 8 are your home activity on the arc length. So please just do this home activity on the arc length. Do this home activity on the what? On the arc length. Right, we're taking a break right now. I'm going to send you the recording before my class starts at 8 o'clock tonight. From 8 to 10, I have another class. And then I'm going to send you the recording so that you can watch and then do the homework 6 to 7. When we meet again, we shall be focusing more on the surface area of revolution, and then we shall do the thoughts also. Right, I think I must thank you for joining us. It was awesome having this discussion. Let me take a short break. We're taking a short break. I'm going to send you the recording, and then we shall meet again at 11. And then we have more energy. Please relax and have more energy. All right. Thanks for now. See you again at 11. I'm going to send you the recording. 6, 7, and 8 are your home activities. So you need to try those on the arc length calculation. You need to find the exact arc length of the curve over the interval. Right. From us, thank you so much. It was awesome having this discussion now. Until 11 o'clock tonight, take care. Right. Until 11 o'clock tonight, take care and goodbye for now. Until 11.